Hello, hello. And we should be live. And I'm tweeting out the link. Now the world knows. Welcome to my first stream of this kind that I've been wanting to do for a little while. I'm going to be prototyping a game in Unity in C#. And this is meant to supplement a class that I'm teaching at NYU IDM right now on game development, and basically pack as much of a full game prototyping experience into a video as I can for my students. But of course, it's publicly available to anyone who would benefit from this as well. So I've got my setup in place. I have the chat room open. All systems should be go. I have a little demo file here that I'm going to get rid of in a moment. And going to get started in just a minute. I'm going to go refill my water, and we'll get started making a game. Okay. Oh, people are on the Twitch channel, or at least one person. Hello, Pederick. Can you hear me? If you can't, mention that in the chat, and I'll see what I can do about the audio. I did go out and buy a new mic just for this, because this is, like I said, something that I want to get into. I want to start doing more, and hopefully my setup will hold up. So what do we got? We got Unity, we got Mono Develop, hoping the font is big enough. I have in my other screen my magic whiteboard. Magic whiteboard, where you can follow along with my quasi-Arabic terrible handwriting. And I'll be using this for brainstorming and prototyping and just taking notes. It helps me to sort of think visually and to write things out. Cool. Audio sounds good. Awesome. All right. So the basic idea here, what I'm going to try and do, and hopefully 2-ish hours is kind of that's kind of how long I'm predicting this will take. Maybe a little longer. I want to go through the full cycle that I've been teaching in class, which is we're going to brainstorm some ideas. We're going to come up with some prototype, like production plans. And then we're going to actually just build prototypes. And this is something we've been talking about in class, but waving my hands around about, how big should a prototype be? What features should you cut out is a little, I think, less useful than actually seeing someone go through the whole process. And, don't have enough time to just build games in front of everyone. So hopefully this will be helpful to some people. So some of this is, this is all going to be as real as I can make it. I am actually writing, I'm going to be writing code from scratch. So you'll get to watch me stumble and fuck up, which is great and realistic. The brainstorming is going to be a little, faked isn't really the word, but I have a sense of what I want to make. I'm going to do a quick mind map and just come up with prototype plans, but I am coming into this with an idea of what I want to try out and make. I'm also, brainstorming on my own, which is a little bit less effective than, brainstorming with other people, so that you can sort of build off other people's ideas. So that part is going to be a little less representative of my actual practice, but the prototyping and building out those prototypes will be. So let's get started. There's a game that I've wanted to make for a little while, which is basically bullet hell where you can't shoot back is the elevator pitch. So I'm going to go ahead and just write that down. And I'll define those terms in a moment. So bullet hell can't shoot back. This has just been on my mind for a little while for a variety of reasons. And let me tell you what I mean by that actually. So we got bullet hell games. Pull up YouTube, mute my browser. Nice. So bullet hell game is basically they tend to be top-down shooters. Sometimes they're side shooters where you control a ship typically, and the number of moving projectiles on the screen is just overwhelming. So you see that all the screen gets covered in bullets, and we've just actually got started here. I could jump ahead to like a boss fight. I've never actually played this game in particular, but this is a genre that I'm kind of into. So there's like three things happening here. You are moving around. So you have like motion. You're firing back. And you have power-ups. And if I was to break down this genre, those are the three axes I think that stand out to me. You have some kind of motion that's crucial because you're navigating in and out of this crazy barrage of bullets. You're returning fire, and you're picking power-ups. So like look at that. So a lot of these games are about sort of understanding the patterns that these bullets move in. The bullets aren't moving randomly, and dealing with that. And I guess what I want to try is, what if we left out firing and we just had a game that was just about moving around and maybe collecting power-ups and dodging these bullets? Maybe terrible. There may be no way to make this interesting. It may be like super boring. But that's the point of a prototype like this, is that those are questions that we're going to have going in. Like, I don't actually know if this is going to be good. The only way I could figure that out is by building up, by prototyping the idea. So just some other precedents to lay out. Removed browsers. So this is a, GamePlow. Yeah, the internet knows. YouTube knows what I mean. So this is a great game that by Vlambeer, Rami Ismail, and JW, super talented game devs out of the Netherlands. Annotations are the worst feature of YouTube. So this is kind of a bullet hell. It's much less overwhelming compared to the other style that I showed you, but the motion in this game is so cool. It just feels so good to control this ship. It's kind of a side view. I mean, yeah, it is a side view, but it's very physicsy. So you're constantly falling and thrusting and jumping up and down and in and out. And the feel of this game is really, really good. And you can customize your ship and pick different combinations of parts that make your ship perform differently. Super minimal, super, super nice. I was really into this game when it came out. And I'd even call, just as a final one, if anyone's been playing Devil Daggers, this to me feels about the same. It's 3D, right? It's not like a 2D side view or top view. I'm going to kill these annotations. But similarly, it's a game about just being overwhelmed by these enemies that individually are not difficult to kill, and that'll probably come up in the brainstorming. But there's just so many of them, and there's only one of you. So you see that the player here is in constant motion, never holding still. There's a gem mechanic where you have to pick up gems to get power-ups. So there's a power-up mechanic in this game as well. Different kinds of enemies, firing back, motion. So totally different way of delivering it, but this game still operates on those three axes. And here, if you get later on, you get these crazy power-ups and like homing daggers. I've never lasted more than 60 seconds in this game. It's so good and so overwhelming. So that's kind of where I'm coming from. in terms of what the precedents that I'm thinking of what I want to try. So let's pop back over here. And I guess I'll start my mind map over here in the corner. And so let's put in the middle, let's just say no fire bullet hell. All right. So where do we start? So, like motion is important. Maybe perspective could be top, down, side view, 3D. Start with the sort of top of my head, obvious ones at first. Motion could be physicsy, kind of like lift trousers. The feel, because I feel like in a game where you can't really shoot back, my guess, and this is just a guess as someone who's made games for a little while, is that you'd actually, all you kind of have is your motion. So the way that feels may be a big part of making this actually work. Power-ups or pickups, right? Maybe they affect the bullets somehow, just completely freewheeling, brainstorming. If anyone in the chat has ideas you want to call out, that's super cool as well. Maybe they slow them down, IDK, make them vanish. I could imagine power-ups affecting the enemies. Affect the bad guys. Maybe they slow them down. Maybe it affects their aim so that they can't hit you. Power up hell. Oh, that's great. Oh my god, what would that look like? Maybe some power-ups are bad? And you can pick them all up, but they like affect you differently. That's maybe a little bit like super crate boxes like that, where you have to get as many crates as possible, but the crates always change your weapon, so it's not always a good thing to, and one of the weapons is really bad in that game, so it kind of sucks to pick it up. And maybe the power-ups affect you. Maybe you have an invulnerable, maybe you become invincible for a bit. Maybe your motion changes. Right, maybe you become faster. Maybe you can like let me write that better. Auto dodge. Maybe a power-up that just automatically AIs around the bullets. What else we got? Coming back to the... Oh, right. So we had, like, invincible. So I wonder how that makes... I mean, it makes you wonder about health. So maybe that... Here, we'll start off. Your health, is it, like, one hit kills you? Or do you have some kind of life? And that connects to the ability of being invincibility. Yeah, power-ups that affect bullet velocity. So you can like slow them down. Power-up that slows down time altogether. That's super interesting. So yeah, that's neither. That's like maybe a power-ups that like. Oh, that's kind of like there's a game called Cinemora, which actually I'm gonna just pull that up on YouTube because it's so pretty. I don't know if anyone's played Cinemora, but it's actually one of the prettiest games that I've played in a while. It almost feels like the Metal Slug of 3D games. I also think Metal Slug is one of the most beautiful games kind of the peak pixel art. Play. Isn't that great? It's so pretty. So this is kind of a bullet hell, but I bring it up because they have a time mechanic. So when you get hit, you don't lose health, you lose time, right? And you can also spend time to slow down time, if that makes sense. I'm not sure if they'll do it here, but there are times when the enemy, you're just so overwhelmed by bullets that you just need to slow down time to like zip in and out of everything else. But they also use time as your health, which is an interesting tension. So you can spend time to dodge bullets, but that if you spend all your time, then you just die. Let's jump ahead. How pretty this game is. Come on, YouTube. So good. If you look at the concept art, it looks exactly like this. It's one of those games where you're basically playing their concept art. So I like the idea of affecting time. That's pretty cool. Oh, time travel. Almost like Braid. This just came up in the comments. Yeah, that. Well, I'm coding this in C#. If I was coding this in Arcadia and I had, persistent data structures, I could do that trivially. But that's pretty cool too. So maybe, all you can do is, try again. Interesting. So good health, different motion. So there's like a physicsy. I wonder about moving around. There's like a cover mechanic. And sort of hide from the bullets somehow. I wonder what else. Yeah, so what is the cover? I guess it could be like fixed parts of the level. Cover could be moving. Physicsy. I guess the opposite of physicsy is like a sort of, I don't even know what you'd call it. It's like a direct. So direct mapping, you press left and you just move left a little bit. I like how the power-ups really sort of blow up. Oh, bounce back bullets at enemy. Pederick on the comments is kind of crushing it with the ideas. So reflect. That's super cool. And we talked about this in class, but the like idea of the details of the power up down the line will be the stuff, quote unquote, in your game. So your mechanic may be that, you have some kind of game with power ups, and then all the individual power ups are the stuff, and that's how you flesh out the richness of the gameplay. Oh, bullets as environment. Oh, that's really good. So that's almost like, where does that even fall into? It's like, that's a new branch. And then maybe that factors into cover somehow. Maybe some bullets allow you to hide behind other bullets, like some slow-moving projectiles allow you to hide behind fast-moving projectiles. That's really interesting. And this is another example of just taking an established genre and subtracting something from it, and then getting, that constraint, opening up the ability to just really think about new stuff. And really, my favorite kind of design, whether it's games or UIs or hardware or anything, is really design that takes things away, not just adds shit. Cool. All right. So let's. I'm gonna call it. I'm just gonna put a box around this so we could find the center more easily. This whiteboard will also export. It's like a browsable HTML at a URL at the end of this stream, so you all can see this afterwards. It's not ephemeral. And I'm also going to be posting this video to YouTube. I confirmed that worked last night. So let's actually go from this and start picking out some things for some prototypes. So we got power-ups seem to be where there's like the most like flexibility in terms of like different ideas and different things to try. So I kind of want to give everything, all the mechanics, some notion of power-ups. But let's start picking some interesting branches and putting together prototypes of them. So we got the most basic thing I guess we could do is we could have some kind of direct motion with fixed cover and maybe like a top-down view. And actually the simplest thing we could do is like no power-ups, maybe just to get started. So I'm thinking maybe it'll be kind of like, this is the player, and you got maybe some sort of cover and a fixed playing area. And maybe you have bad guys coming in, firing bullets, and you have to run around and dodge and survive, and then so there's a timer. So that's the sort of a very simple way of like I'm trying to arrive at like the most reduced versions of some of these ideas, and then maybe there's a power up. Right? But another important thing is to start building up a bunch of prototype questions. Right? You wanna, not just jump in and make a bunch of games, but there's stuff we don't know at this point, like. How important are power-ups? Are they make or break? Does this game work without them? What kind of patterns should the enemies have? Right? Like, if they're just moving on a simple straight line, is that enough? Does the game become interesting when the patterns of enemy motion are actually interesting or are complicated? I'll add to that list of questions as we build it out. So this is one possible prototype where we'll say it's if we're building the game design document here, the one-liner would be that this is like a fixed area with cover, enemies. I guess they just sort of come through the area. Just making this up. Enemies come through and shoot. So even something as basic as this, and we'll have two variants, one with and without power-ups, really pretty explicitly just to test and answer this question. Even something as simple as this, if we want to start breaking it up into a punch list, and we can, before we do that, we can get more detailed with the game design document of the assets that we might need. But right now I'm just going to probably just use colored shapes as the assets initially. I might grab stuff off of kenny.nl. If any of you have ever used that, it's a great source for free art and free assets. But even just this basic sketch, there's quite a bit going on. So we've got like a timer. We've got the terrain, which is the, what you'll be able to hide behind. We've got enemies. and we've got the player. This is the 4 basic things. And the player is going to have some kind of motion driven by the input, and the ability to die. It's kind of all you can really do is just, the game will just run until you die. So I guess the win state that's emerging from this is that you want to last as long as possible. And here I'll add some variants, like die. Maybe there's 1 hit, and then health. And these are 2 variants we can try, right? I don't know, one may be more interesting than the other. And I'd want to build a prototype so we can switch between the 2 and figure out which one makes for a richer or more interesting game. And the enemies are going to have motion patterns. They're going to fire bullets, which are also going to have their own motion patterns. And here's the thing. And this is why doing this is important. You start to see this kind of stuff. Maybe I wonder if enemy bullets can hurt other enemies. I wonder if you can get enemies to sort of shoot each other in the way that if you ever played Doom, that was the first game that I saw that did that, and it blew my mind. You could trick 2 enemies into shooting each other, and they'd start fighting. I think people called it monster fighting. It's pretty cool. So, because I was about to say that enemies don't have health, but maybe they do. And this, we can go back to our brainstorm and even add that if we wanted to. So here we have enemies shoot each other. Oh, Pedrick is saying he's wondering if the player's size would be important. Oh, that's a good point. Yeah, the player has some kind of size that we're going to want to tweak and play around with. Pedrick's also saying, what if the player could control the size of the ship or character being small? Interesting. Cool, yeah. So I'm going to go back and add that to the power-ups. So here we have under effects U, we could branch off and say, your size, more technically your hitbox is what that would affect. So it's important that this project is not linear, right? It's not like you have, one step leads into the other step, which leads into the other step, and now you have a game. It's really, every step at any point you can sort of go back and sort of massage earlier ideas. And of course, once you have this working prototype, this whole thing repeats itself. So it's an iterative process because you're going around the circle, but you can also move back and forth in steps and go back to an earlier step and add ideas. Oh, C.Wright is saying maybe bullets can affect size, like Katamari style. Oh, interesting. Maybe every bullet you take makes you bigger and more vulnerable somehow. Oh, that's interesting. So I'll branch this off of enemies, and I'll say the enemy bullets, and maybe the bullets affect your size. Oh, this is great. I'm glad that the chat is allowing this to be more collaborative and less me pretending to collaborate with myself. That's pretty cool. So health, and I'm gonna just add that here. Shoot each other. And the terrain, maybe the terrain also has health. Like maybe your cover can slowly erode over time, kind of like Space Invaders. And then the timer, I guess, will have the speed that it's running at. Oh, it'd be interesting if we're counting up to see how long you've lasted. And you could get a power up that just makes the clock run faster. So if you like survive for 5 minutes in real time, but you got a power up, that actually ends up being like 10 minutes in game time. And here we have also the power ups. And the power ups will affect basically all these parameters, and I'll jump back to the mind map for ideas for that. But here we just have the idea of power-ups that you'd run into and pick up, and they tweak some kind of value in the game. So we could, I usually have my students come up with a bunch of these, which is great. You can come up with a bunch of basic prototypes, but for this stream, I'm going to take this one and break this out into a punch list, and because I want to get a working playable game as soon as possible. And it'll start telling us what is interesting and what is not interesting about these different ideas. And ideally, we'd be able to take that and brainstorm on it and build out some additional prototypes. So the next step is to turn this into a punch list, because this is still just rough. It's almost like a focused brainstorm on just this basic premise of a fixed area with cover and enemies sort of floating through and possibly power-ups. So a punch list for this now we get technical. Now we break it down into the assets and the code that we need. So we're going to have oh, right. And the other thing I'll say is that this punch list is a thing that we turn into a Trello board or a to-do list that we share with the team if there was more than one person. But I'm going to use whatever I write down here as a checklist, and I'll cross it off as I get stuff done. So we're going to need some kind of timer that counts up. And it's going to have to be displayed. Right, so it's going to have the internal logic to count up and some kind of way of rendering the current time to the player. We're going to have the terrain. That's going to have, you know, hitboxes. Maybe, yeah, I'll add this. Collision logic, so that, you know, when it takes, when bullets hit it, it could do something. It may be that, you know, the terrain does nothing, but like we said here, that, you know, maybe the terrain has health and crumbles over time. So I'm going to at least put in the broad strokes of allowing the terrain to react to taking damage from bullets. And there's going to have to be some kind of layout. And now just adding this makes me sort of want to go back and say that, oh, maybe the terrain is procedurally generated in terms of its layout, or it's just designed by hand, which for the initial prototype, designing it by hand will probably be the quickest in Unity. Cool. So anything else the terrain should do? It's got to have some kind of notion of hitbox, take on some collision, and layout. Let's leave it at that. We'll add to it if we have to. Now things get a little more interesting. Before we talk about the enemies, I'm going to talk about the bullets. So they need collision, logic, and flight logic. Right? They're going to be moving through space. Maybe they're moving straight. Maybe they're moving around in, weird patterns. Some kind of place where we can do that. What else? Is that it for the bullets? Yeah. And I mean art also. The terrain also needs art. Even if it's just a colored box, we need, that's a thing that needs to happen. It's, more than 0 seconds of work. Then following the bullets, we have the enemies. They're going to need some art. Enemies are going to need flight, logic, collision logic. This is where if we want the enemies to take damage, we would that's where that code would go. And then finally, this is kind of like aiming logic. So here we're saying, you have a enemy that moves around somehow, and if it takes damage, it might do something, but it's also figuring out how to fire. So this is still very high level. We're not talking about components or scripting or anything. We're just saying we know that at the very least, this part of the game needs these 3 things. The enemy's got to move around, enemy's got to react to taking damage possibly, and the enemy needs to know how to aim and fire. And, all of those need code. There's that's not going to happen on its own. And then finally, the player needs art and motion logic. So that'll take it sort of a movement from the input. Definitely collision logic, because we want the player to be able to die. And I think that's basically it. These are the broad strokes. So, like I said, the goal here is to start building a game as quickly as possible. Because the longer, this is all very important, and we've discovered a lot of sort of ideas have come out just by building up these lists. But you really only start to arrive at answers when you have a prototype that you can play. So that's what we're going to do next. And I'm going to leave you all for about 30 seconds while I run to the bathroom, and I will come back and we're just going to start writing code. So here we go. Okay, so let's get started. I like to start with the easiest things first. To be honest, it just gets me in the groove. The things that are less interconnected. This is kind of an abstract thought, but the hardest parts of software in general tend to be the parts that are connected to other parts. So, here we have the enemies deal with bullets, and the bullets sort of maybe can hit the enemies, and they can hit the player, and the player interacts with the terrain, and the bullets interact with the terrain, and so do the enemies. But the timer is kind of just, hangs out above everything else. So just looking at this, my instinct is that maybe the timer is the easiest thing to just start off with. So let's do that. Okay, so I had this little demo script that I wrote just to sort of test out font size and everything. I'm going to get rid of it. It's gone. And it's gone. So the project is still called dry run because this is what I was testing out last night. So I'm just going to go ahead and start a new project. I'm going to call this, no shoot bullet hell. Oop. And it's going to be a 2D game. And I'm not going to save. So Unity has to shut down and restart in order to edit another project. And here we are. Not going to update Unity while streaming live. The layout that I like and that I would encourage certainly my students and others to use is I like to go to 2x3, which gives you this layout. I like to put my project tab under my hierarchy tab. And then I like to set the project tab. I'm going to click this little hamburger button. I'm going to set that to one column layout. This is the old way of displaying files that just makes a little bit more sense to me. This gives me also more space to see the game and the scene. And then finally, and I do not know why Unity doesn't do this by default, you go to Window and hit Console. I'm going to drag the console under my inspector. The console is what will show us scripting errors, which we will definitely have. So this is my ideal Unity layout. And it's what I'm going to be using in this stream, and that's how you arrive at it. So let's start making the timer. So I'm going to go to Game Object, create empty, hit Enter, and call this thing timer. You'd also right-click and hit rename. I'm going to be using more and more keyboard shortcuts as I go along, and I'll try and call them out and indicate what I'm doing. So the timer, before I write any code, I want to get as much of the built-in Unity stuff squared away as possible. So we know from our list that at the very least, the timer is going to have to display the time. So we need some kind of Unity way to render the time. And because this is 2D, I'm going to use Unity's UI text component. And if you click that, we'll see that Unity adds that. I'm actually remembering now, right, so that's not going to show up. The way Unity's 2D UI works is a little involved. So I'm actually going to get rid of the timer. And the quickest way to do it is to go to actually the Game Object, UI, and then hit Text. And you'll see why in a moment. You see that it created this text object, but it also created a canvas object. So in order for Unity's 2D UI stuff to work, it all has to be under a transform that has this canvas component. And that deals with the way that the 2D UI stuff is rendered. The sprites are not exactly, the sprites are not constrained by that. So we're going to be using Unity sprites to display our 2D graphics. But the text, it has to be inside of a canvas. And this is where things stop being abstract and broad strokes. And it's just, you're dealing with a particular engine that was built in a particular way. So you, over time, learn its rules and learn to conform to them. So here, if I type in, I can't see it, but if I zoom out, you see that I have this gigantic new text. Oh, and it is actually there. If I zoom in to the corner, you see that it says new text. So this is what I mean by, I haven't written a line of code yet. I just want to get the text to display correctly and work correctly from the inspector. And then I'm going to write some code to just basically do what I do in the inspector and just automate that and do that at runtime. So a couple of things that are wrong. The text is too small. It's in the wrong position. So I'm going to just use the inspector to center align the text, middle align the text, make the font. So if I make the font bigger, it gets too big. So I guess we should position it. The way the canvas works is it gives you this rectangle that's going to represent the screen, and then you can visually lay out your stuff, which is, not bad. It's pretty cool. So I'm just roughing it in. It'll do like snaps and stuff for you, which is pretty cool. And now I could bring up the text size to something that's readable. So you see that here, new text. So we could either have like 345. So that's kind of what it'll look like. Maybe let's actually go to the main camera and set the background to be black. And set the text to be white. Why not? And it's using Arial, which is kind of a gross default font, but for the prototype, that should be okay. And now to change the text, we just change this text field on this text component. Hello. And if I hit play, of course, that'll just kind of hang out. There's no logic associated with it, so we're playing, and that number is just staying. So what I'm going to do instead, what we're going to do next is now we have it sort of laid out, and we see in the inspector we want to do something like that, kind of. So I can simulate it manually. And now we just want code to do what I just simulated. That's the way I like to think about prototyping Unity. Is like fake it in the inspector, and then, okay, what does the code look like to do what I just did in the inspector while the game is running? So I'm going to add a component. It's going to be called the timer. It's a new script, and in C#. Oops, Unity's thinking. So I double-click the timer file, and that caused Unity to create a new C# project for me and start editing that script. So the timer, I'm going to rename this game object to be timer. So we have the timer game object and the timer script, and these are different things. Remember, Unity, you can attach a component to anything. So if you want to have multiple timers, you could do that. If you just want one timer, then don't attach this script to more than one object. But that option is always available to you. So at the very least in the timer, we're going to have the notion of time. It's going to like record how long you've been playing for, or how long you've been alive for. So I'm going to create a variable which is the time alive. Can people in the chat tell me if the code is readable? I made the font a little bigger for the stream, and hopefully it's big enough. But if we jump back into Unity, we'll let it think for a moment. And we see that gives us this nice time alive script. So this is how long you've been alive. And we can even go negative because it's a float, but we won't. So while the game is running, I'm not going to do anything when we start up, but the update method is going to be called every single frame. So what we want to do is increase the this time alive variable as long as you're alive. So for now, let's just try something quick. So I'm just going to add 1 to it. And I'm just going to watch what it does in the inspector. So I haven't hooked this up to the text renderer at all. That'll come in a moment. Unity's thinking. And we see that time alive variable starts to go up. Now it's going up too fast. It hasn't been 200 seconds. What we want is it to increase on natural time. And the thing is, this update method is being called once per frame. And if we're running at 60 frames in a second, then we're going to actually add 1 to that variable every single 60th of a second. So every second, we're going to actually jump up by about 60. So Unity actually, the solution to this is Unity has this this field built into their time class called delta time. And this will always be the number of seconds since the previous frame. So delta time will always be about, is roughly equal to 1/60th of a frame. Another way to think about it is if if you multiply it by 60, you'll get exactly 1, if you're running at 60 frames per second. I'm trying to use concrete numbers just to make the example a little bit clearer. But it's basically like the tiny slice of time between the previous frame and this frame, and that all adds up to 1 second. So if we multiply it by 2, well, actually, let's just run this to see what that looks like. So we have 3, 4, 5, 6. Now we see that we are actually running on natural time. Now what happens if I multiply that by 2? And we jump back into Unity. Oh, it went away. Now we're running in double time. So time.delta time is the time slice between this frame and the last frame, and that may be confusing, but I'll leave it at that for now because I want to move on with the prototype. So the time alive, is going to run. We're going to leave that at just adding delta time every frame, and now we have a timer that's counting up seconds. So we actually just accomplished that. And crossing things off lists are, I don't know, that makes me really happy, and it makes me feel like I'm making progress. So I'll be doing that. Now the next thing we need to do is to display. And we see here now that this display is just kind of hanging out and it's not connected. So the way we want to take this value and connect it to the this text component. Now, a lot of Unity code comes down to components reaching over and talking to other components. That's actually the majority of what Unity-specific code looks like. So I want my timer component to reach over and tell the text component to update its display every time the time changes. And we could look up the documentation on how the text component what that API looks like. But the nice thing about MonoDevelop is we can actually use the inspector and MonoDevelop's autocomplete to kind of guide us towards the right code. So the way we reach over to another component is we ask for, get component. That means, give me a component on the current game object, whatever game object this script is also attached to. We use the angle brackets to tell the system the type of component that we want to get. In this case, it's text, and it might actually have to be UI text. I may have to do... Yeah, I have to do that, which is a little annoying. But the Unity UI stuff exists in a separate C# namespace, and you have to pull it in to do that. So it's a little annoying. But now I should just be able to say text. So asking for the text component, and we need empty parens because that's actually a function that we're going to call. But the nice thing about doing it this way is that now MonoDevelop actually knows that that is a text component. And if I write dot, it gives me all of the fields and methods that a text component has. So I don't even need to look up the documentation on this stuff because it gets pulled in here. Like I could say, oh, the default material is returns the default material for the graphic, which is not what we want. But looking in the inspector, we can see that there's this field is labeled text. And again, the inspector is not always 100% accurate. There are times when you will just have to look at the docs. But if I just type in text, see the autocomplete finds a property called text that is the string value this text will display. That's what we want to set. So if I say text equals time alive, let's see what that looks like. Save that, pop back into Unity, and now it's upset. This is why the console is important. It says, cannot implicitly convert type float to string. So time alive here is a number. It's a floating point number. And the text, it's expecting a string. So I actually need to turn this into a string before I can hand it off to the text. And the simplest way to do that is just to call toString. Every object in C# has a toString method that you can do that to. There we go. Now, here's an important point. It's working. We have a timer that's counting up. It wasn't in the initial format that I sketched out, where you have the minute and colon and seconds. And we could sit down and do that. But for the purpose of a prototype, this is great. This is all the code you actually need to achieve these 2 points. And what's important about prototyping is to not get hung up on details like formatting, because at this stage, will the game be better if you had, minute, colon, second format? Will that tell you anything about the mechanic? Probably not. So the cleanup can happen a little later. If you think the decimal point is visually distracting, that's the only sort of formatting argument that I can sort of put in my head, is that you're seeing this thing move, that might distract your eye. We can round it. So Unity has a mathf class that has a bunch of mathematics in it. And we can turn that into a string now. Let's see what that looks like. Oops, I did not save. And that's perfectly fine. The way I approach this stuff is that is more than enough of a timer for this stage of a prototype. Notice how little time I spend, or how often I make a change and then pop back into Unity. The tighter that feedback loop, the better as far as I'm concerned. You want to always be checking to see if your code is throwing errors, if it's doing what you want. You want to be moving back and forth between your code and and what the code is doing. Also notice that there's basically just 3 lines of really meaningful code in this example. And that really achieves everything that the timer needs to be. It doesn't need to be more complicated than that. So I took some time breaking some stuff down, syntax-wise and API-wise. I'm probably going to start moving a little bit faster as I build out some other scripts, just so I can get a couple of prototypes done in time. So here's our timer. What's next on the list? So I'm going to cross this off, and the timer's done. Now we could create some hitboxes with art. That may be a fun, easy thing to do quickly. Let's see what that... Just going to pop into canny.nl and grab some art. Totally royalty free, which is kind of amazing. Go to their assets. And this is, haven't really decided on a perspective, but that's not super crucial for this, but I'm just going to say top down. This could work. You got some terrain stuff. You got some power-up-y stuff. You got planes. You got little tanks. Let's see what else they have. Roguelike indoors, that could also work. Roguelike dungeon and cave. Ooh, are there people? That's a little detailed. I may just go with that first one if I don't find anything on this next page. Ooh, robot pack. Could be a robot shooter. Oh, roguelike characters. That might be what we want. See the robot pack. No, they're cute, but they're a little side viewy. Nah, this is more complicated than I want to get to. It's cool that you can mix and match parts. Okay, let's just go with this. Again, you know, it's in the 2D stuff in Unity, using sprites is quicker than just solid colored shapes. But you can also, and Unity doesn't have any built-in sprites, which is a little annoying. So they have a tile sheet that we can pull stuff out of. It's all on a grid, and they have separate PNGs. I'm just gonna pull in the sprite sheet because that'll be the quickest thing to import. And they have it at 2 different resolutions, at the Retina resolution as well. Oh, and you have little dudes. Oh, that's great. This is exactly what I want. So let's pull in just the smaller one. And I'm going to tell Unity that this is multiple sprites. I'm going to go to the sprite editor. I'm going to apply that. That's fine. Oh, and we're playing. So I'm going to jump out of play mode. I have a habit of just always staying in play mode, which Unity sometimes doesn't like. So we're going to slice this on a grid. And these are, what is it? 1, 2, 3, 4, 5. Oops, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 13 rows and 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. 23 columns, 13 rows. Is that okay? Yeah, that's great. Cool. Let Unity think for a moment. Should be good. And I'm going to filter. Not going to generate bitmaps. This just avoids the textures getting a little grungy at times, and just leave them true color. So now, basically, Unity is not going to filter any of these graphics, or try and get clever with them at different sizes. And let's see what they look like in the game. See, they all got auto-generated names, which are just fine. I mean, we generally won't be looking things up by their names. We'll be just making references to them. I want one of the players. I want to see what they look like. No. There we go. So yeah, I want something with transparency. Okay. No. Send it to 0, 0, and there we go. That's kind of a cool thing. A little buddy hanging out. Move it around. Awesome. So the next thing we wanted to try was terrain, and with some hitboxes and collision logic. Now we start to get into the tangly bits. It's like hard to test out collision logic without anything to collide with. So we're just gonna sort of make some incomplete things until everything is on the scene, and we can start hooking things up, if that makes sense. So I'm just going to throw down some terrain bits. A faster way to browse this stuff is to actually jump back into the sprite editor. Then you get a view of the whole thing. And then when you click on these different sprites, you see that you get the name that Unity assigned to it. And you can give them all custom names if you want to. That also works. So I'd probably give these players custom names just so that I can find them more easily. But for the terrain, what a question that we didn't write down is, what shape should the terrain be? And the simplest thing, whenever I'm faced with a question like that, I just wonder, okay, what is the simplest thing I could possibly do? And in this case, it's just a box. So I'm just going to use this gray box, tile sheet 201. That's going to be the different terrain that you can hide behind or take cover behind. So tile sheet 201, let's find 20. Or actually, so there's a couple of ways that you can add this to the scene. You can drag and drop the sprite in as you saw, or we can create a new game object. I just hit Command-Shift-N to do that. I'm going to call this terrain tile. I'm going to add a sprite. Oops, I didn't spell it right. The sprite renderer. And now I'm going to click the little circle next to the sprite renderer, and I can do a search. 201 gives me that tile immediately. And here's one terrain tile. So what do we got? We got the art is taken care of. Should give it a hitbox. So the box collider 2D. This is what tells Unity the shape of the thing. And Unity is pretty good at figuring out the default size. So you see that those green lines that appear when I drag those values out, that's the hitbox. And Unity already gave us a snug little hitbox around the tile because it knows the size of the tile. Let's go ahead and cross that off. And I'm gonna leave the collision logic off for now. I'm just gonna lay them out in some random arrangement. And there's some level design for you. Cross that off. So again, notice that speed is the only thing that I'm interested in right now. Like that, I spent no time worrying about this level layout. That'll come later. Right now, the real anxiety that I should feel, if any, or the pressure that I should feel is that I want to get something playable as soon as possible, and then I could start figuring out what to tweak and what to build on. So I'm just trying to get to that state as quickly as possible. So we have a timer. We have a basic terrain. Before we do the bullets and the enemies, let's do the player. So I'm going to create a new object called player. I'm going to give the player a sprite as well. I should have figured out the name of the sprite when I was in here last. But so we got got a couple of options. That looks like a World War II soldier. I'm going to use this brown visor dude. So 247 is the name Unity gave it. I'm going to rename it just as a demo of what that looks like. Let's call that player. And I hit apply so that Unity applies that new name. And now if I go back to my player object and try and search for sprites, you see the player is right there. And that makes it easier to find. And there's the player. And whoever brought up the player size in the comments was, I think totally on point. The player just now at an initial glance is really, really small. So that may be something we want to play with. But this is what I mean by getting something just out there, and then the game will start to tell you what it wants to be, or at the very least, what things to try. So I am now curious about, does that make more sense? Is this what we're talking about? These all become very different games. Let's leave it at the default size for now. I'm going to give this guy a circle collider. So now that's the bounding box of the player. Again, is it bigger or smaller? that's the kind of stuff that we'd want to playtest. And these are the questions that we want to answer and just also continue to ask. We want our prototypes to both answer questions and generate new ones. And that's how we move forward in the process. So we have a player with some art and a hitbox. And now we want to give the player some kind of movement logic. So I'm going to call this player mover. And there are, some scripts will make sense to be on multiple objects. Like when we introduce enemies, their movement logic will be on multiple objects. Some scripts you'll only ever write to live on one object, in the case of the player. But because of Unity's entity component system, it doesn't really it doesn't distinguish between them. A script is just a script. So I'm going to double click on player mover, and we get that code on the side. Why are you? Oh, okay. It was all red for a second. I was wondering why it wasn't picking up the classes. Player motion, again, for an initial prototype, we're going to make this as simple as possible. I'm going to say if input, nope, not iPhone utils, input, get key left. So let's look at the docs for get key real quick. Returns true when the user, oops, and I made that disappear. Returns true while the user holds down the key identified by the name. Think auto fire, which is nice that they even threw that in. But Unity has a name for all the keys. It's in the documentation, but the arrow keys are just left, right, up, down. So if you're holding, again, this is being called every frame, and every frame you're going to check. If you're holding left, transform, translate, -1, 0, 0. Else, if you're pressing right. Is this the best way to do this? Probably not, but again, we're trying to get to a playable state as quickly as possible. Up, and then down. Should there be a player speed? Should we be using delta time? Yeah, probably. But I want to see this in the game like right away, as soon as I can. Woo, okay. So now we see that. It's doing the basic thing, but the details are wrong. It's way too fast. But it basically works. And again, that's a really important, there's almost two sides to writing code like this. Like, okay, does it basically work? And then does it work in the particular way that we want it to? So here we see that the speed is way too fast. JPlur is mentioning that in the comments that we might not want to use else for diagonal movement. That's an excellent point. And that feeds back into what kind of motion do we want for this game. So if we take all the else's off, so if I'm going to press up and left at the same time now, and you'll see that left wins out. I can't move diagonally. So let's bring in speed, and then we'll see if we can deal with diagonal motion. So you'll see this again. If we want to be able to talk about how many units you're moving in space per second, we need to bring in delta time again. So I'm going to create, again, I'm going to start moving a little faster. So I'm going to want a speed variable. And now instead of moving by -1 and 1, we're moving by minus speed and speed, whatever speed happens to be. You let Unity think. And now we have the speed variable. So initially it's the same, but if I make speed 0.1, now we're moving a lot slower. 0.01. Now we're moving a whole lot slower. But without delta time, where this is the speed, what this means is, how many units do you want to move every frame? So your numbers are going to end up being quite small. That's why I like to multiply by. Let Unity think. Again, notice I make one change, I pop back in. I make one change, I pop back in. Now we're moving really slow because we're moving 0.01 units per frame. But if we bring this back up to 1, now we're moving 1 unit per frame. And now we can experiment with like, oh, what if I go like 4? Now it's 4 units per frame. That's a lot faster, but it's not, it's manageable. And I could think about, seconds. Now we're moving 4 units per second because we have delta time in. That was my mistake. So, but again now, if I press and hold up and left, that doesn't, I don't get diagonal motion. So there's two things that we can do here. Like diagonal motion didn't come up anywhere in the brainstorming or the punch list. But the way that I happened to write this code made, someone in the comments notice it. And this is what I mean by the game sort of revealing these details to you. You can't, once you have working code, it's going to be, this kind of stuff is going to come out because you can't be ambiguous. You're actually like building a system. So we could do one of two things. We could add that in right now. So I'm just going to remove these else's and that should do it. So now we have diagonal motion. Why'd it go black? That's very strange. I do not know why the camera just disappeared. We'll restart. So we could do it right now, or we could have add it to the next prototype list. That's what that would look like. So whether or not you notice something and act on it immediately, or notice something and just, schedule it for the next prototype, it's up to you. It's up to your workflow. Things that are simple, you might want to like react to right away. Things that are more complex, you might want to push off down the line. Again, the important thing is to not get hung up. To not get stuck, is to be just constantly moving forward towards a playable state. So I'm just going to leave this diagonal motion in just because, there's an easy fix. But I'm going to leave this in as the next prototype as something to think about. Like, is diagonal motion something we want? Is orthogonal motion something that's, maybe that constraint is more interesting? But that's something that we noticed via prototyping. And let's see, what's next on the list? Yep, so we got the player, you got some art, you got some motion logic. And we got collision logic for the player. Which is, I guess it's two things, right? It's like when you collide with the bullet, you should die. When you collide with the terrain, you should stop. That's basically it, right? And maybe enemies kill you too. So let's see what happens when the player hits the terrain. Ooh, why is my render texture warning destroying active render textures? Switching to main context. I don't actually know what caused my camera to get all upset. I don't know what that error is. Oh, very strange. Has anyone in the chat seen that? I'm just going to go ahead and just create a new camera that is orthographic. No? Weird. Oh. Is the stream doing that? Ooh. Oh, I hope the stream isn't doing that. Oh, that is no good. I'm going to have to Google this. Hooray, real game development. All right. Unity throwing an error that I've never seen before. Let's see what Google says. Game view goes dark in Unity 5.4. That's exactly the version that I'm on. Oh, I hope this isn't a show-stopping bug. El Capitan, that's what I'm on. I'll close the game view and then bring it back up. Close. And game. There we go. Oh, God. The stability of modern software. So there's some bug in Unity that causes that to happen. Good to know. Good to find out about that on the stream. So I may have to do that some additional number of times if that ever happens. But where were we? Right. So we want to see what happens if we bump into these guys and nothing. Even though they both have colliders, they don't interact in any way. So we need to give them all, we need to at the very least give the player a rigid body 2D. I'm not going to go into the details of the physics engine that will happen in class later, but I'm just going to sort of make this work. So there's no gravity, and you are kinematic. And let's see that. We move. Yep, still doesn't do it. And we probably need to give these guys. So I can select multiple objects and affect them all simultaneously. And you have no gravity applied to you, and you are also kinematic. Let's see what that is like. Oh, right, and it's kinematic, which means that if I'm doing transform.translate, I will actually just be punching right through the object. So what we want is Unity's physics engine to prevent us from walking through the barriers. But because we use transform.translate, that will always move your object to that position regardless of anything in the way. It basically doesn't consult the physics engine. So this is another example of this shape that I quite like. Oh, where's my little iterative shape? I'll draw it again if I can't find it. The idea of, just keep doing things as simply as you can and only go back and complicate things if you absolutely need to. So I'm about to go back into the player movement and make it a little bit more complicated, but I know that I need to because I want the player movement to, to consult the physics engine. But I'm a big fan of that as opposed to building things sort of intricate and quote unquote complete to begin with. I try and see how far I can get with the simplest possible thing. And if you have to go back and rewrite some code, it's really not the end of the world. So what we want is we're going to need to get the rigid body 2D component, and I think it has a right. So it has a move position, and its move position will move the game object to that position. It's a lot like transform translate. But it should consult the physics engine because we're doing it via the rigid body component, not a transform component. And if there's anything in the way, it should prevent us from moving. So it's going to work a little bit differently. We have to compute a new x and new y. So var new x equals 0.0. And var new y equals 0.0, and I think my monodevelop is, just rewrote that as, yeah, there we go. And now we're going to say is if you're pressing left, we're not going to go ahead and move you right away, but we're going to say your new x is going to be your transform position x minus speed times delta time. So because the way rigid body works, we can't, it doesn't have an API that says like move by this much. We have to give it a new position. So we're actually going to compute a new position for it. So if you're pressing right, then your new x should be your current x position. I know. Oh, right. Equals. If the autocomplete isn't working, it's usually a sign that there's a syntax error somewhere. Right, so there we go. Position.x plus speed times delta time. New y equals transform.position.y plus speed times delta time. And otherwise, new y equals transform.position.y minus speed times minus speed times time.delta time. So by this point, we've computed some new values, and now we can say, okay, rigid body, move to this new position. And it wants a new vector 2. And now we can just say new x and new y. So we compute new coordinates, and we move to those new coordinates. And hopefully, by doing it through the physics engine, we should get Unity to naturally prevent us from moving through moving through the terrain. I didn't like something. Line 19. Oh, right. So the problem here is that the new x and new y, C# guessed them to be of type double, but we want them to be of type float. So we can either put little f's at the end. It is annoyingly picky about doubles versus floats. I don't actually understand why. The other thing we could have done is explicitly given it the types. This will also, not double. No, that'll definitely not work. This should work. I hope it'll do the conversion. It should do the conversion. Oh, and it doesn't. And it tells you what to do. Add suffix f to create literal of this type. Yeah. I don't actually understand why C# is as finicky as it is about double versus float conversion when all kinds of other stuff can go wrong. But, that is the language. So let's see if that worked. Ooh. So I'm holding down and I'm letting go, and the position is just popping right back to the center. Why is that? Does it want the rigid body's position? It should be. Well, let's look at it in the inspector. It should be updating. So as I'm holding it, oh, you want to see the bug? Raise your hand if you can see the bug. I can't see you raising your hands. But the problem is I set the new x and new y to be 0, and then only when you're holding down one of the keys do we compute it based on your current position. So when I'm not holding down a key, none of this executes, and we move to 0, 0. So what we actually want is boop. So we always want the new x and the new y to be the current position. And then this will work. We could also refactor it to not repeat transform position x and y in here, but let's see if that fixes it. Unity's thinking. There we go. Now we're moving. And it's still penetrating. That's super frustrating. Player, and the terrain definitely has a hitbox. Let's try turning off is kinematic. I think that may be what's doing it. There we go. That's what it was. Oops. Now we get to have fun with the Unity physics engine. So is kinematic basically tells the physics engine that our code is going to be responsible for moving the object. They're rules that, I'll be completely honest, I usually end up fiddling with until I just reflexively saving until I get it working. But basically, we are using code to position the object, but we have to leave off is kinematic because we're basically asking Unity to override our position sometimes if we collide. So check this out. We run in, and now things move away. So that's interesting, right? This is what I mean by the system just building things simply and seeing what they tell you. It's like now we have cover we can push around. And I'm just going to pop into the other prototype. And I have pushable cover. So the idea of movable covers kind of came up in the brainstorming, but the idea of cover you can push around, maybe you can sort of construct little forts for yourself or little alleyways to protect yourself as you're moving through the space. So really allow and be open to bugs like that because they could be interesting. And that's what makes game development different, I think, than more traditional programming, that bugs can actually be really informative information. So for this prototype, though, we don't want the terrain to be so easy to push around. So I'm going to try removing the rigid body on the tiles themselves. And I think that makes them immovable. I need to try this to remember. And it does. Great. So they basically have infinite mass when they don't have a rigid body attached to them. So here I'm pressing left. I'm holding left. And I can't pass through this object. But you see that I can still rotate around it. Because I'm basically what Unity is doing is I have this square, this box collider, and the shape of the player is a circle. And if I move forward, that's going to cause rotation, and it's going to start spinning. And so spinning is not something we really wanted for this prototype. So we can either freeze the rotation of the player. That would do it. So you see we're not rotating anymore. Or you can give the player a box collider as well if you wanted. That would also work. So another thing to realize is that even the simplest prototype takes time. And you really... biting off more than you can chew is really easy to do. So you want to start as little as possible so that you can get to a complete playable state. So we are stopping when we hit the terrain. So I didn't have to write any code for that. Sometimes some of the logic is just setting up your engine correctly, getting Unity to do the work for you. And now we're going to need to introduce bullets and enemies so that we can do the dying logic. So let's just create bullets independently of enemies first. So that's what I'm going to work on next. I'm going to create a bullet object. It's going to have a sprite. And I keep forgetting to actually, let's just go through and name all the sprites that we're going to use. That's probably a better way of approaching this. So this little yellow thing is a nice bullet. That's cool. And the enemies, let's make our enemies these green ships. That's just an enemy. We're applying. Great. So we go back to bullet, and now it's just easier to find the sprite. Let me just bullet. And move it away from the player so that we can see. Everyone see that little yellow, thing. And the bullet's also going to have a collider. I'm going to make it smaller. Unity didn't really guess the size correctly, but that's good. Now we're going to give it some flight logic, right? That's the next thing. What do we got? So art's taken care of. And yeah, we want to give flight logic and some collision logic. So let's go ahead and create I'm going to give this let's give the flight logic first. Bullet mover. I changed my mind. I'm gonna get rid of that. No, I'm not. I was gonna make a more specific, like a bullet straight mover, but down the line if we want to like vary the different movement patterns of the bullets, we can do that. But for now, let's just keep it simple. I'm gonna bring over some stuff that I've noticed from the player that we're probably gonna want some kind of speed. Not gonna do anything at startup. And every on update, we're going to basically want to move the bullet along this green arrow. That's a way that I like to do it. So if the bullet is rotated a bit, you still have this green arrow to move along. And the green arrow in Unity is transform dot up. The green axis of the transform in world space. So they even like label that. That's the y-axis basically. So again, we're going to be using the rigid body. Could go ahead and add that. I'm going to give it a gravity scale of 0 because I don't want gravity to affect it. But I'm not going to make it kinematic. We're going to. Is this the way I want to do it? No, let's not do it with the rigid body. Actually, let's try it. I'll be honest. I don't off the top of my head know what's going to be the quickest and best way to do it. So we'll just experiment. So like I said, the transform.up is the green axis, and we're going to want to move along that green axis. So to just capture that motion, maybe before even worrying about the collision. So that was me. Like I was trying to figure out the motion and the collision simultaneously. Let's just make it move the way we want, and then we'll worry about the collision. So to make it move, we're going to, we have this direction and a nice transform dot position plus equals transform dot up times speed. So this is a totally different way of doing it. We're actually updating the position using the up direction, and we're multiplying it by speed delta time. So this is starting to look like code that this is production code as far as I'm concerned. This I've had a lot of motion scripts that look exactly like this. And if we run this, it should not move because speed is 0. But if we bring up speed a little bit, we see that it does start moving. And this is nice because if we rotate, I'm just manually rotating it, and it's going to stay along that path. So this is a nice way to begin or to predict motion patterns for this object, right? Or to set the stage to build out motion patterns for this object. It's a nice one-liner. It's basically you set your position to your current position plus the direction of that green axis scaled by speed and delta time. So flight logic is basically taken care of. And now we want to make this collide with things. We want to make it, if it collides with the terrain, we want it to disappear. If it collides with the player, it kills the player and stops the timer. And if it collides with anything else, I'm actually not going to specify. We'll see if we get to that, to making enemies kill enemies. But that at the very least, we have to be able to collide with terrain and vanish for the cover mechanic to work, and we have to be able to collide with the player and kill the player for the basic shooting mechanic to work. Bon. So we could put the collision in the same component, but I really like small focused components that do exactly one thing. So I'm actually going to create a more generic component, which is kill on collision. Boom, boom. Give it a second. Cool. So now we can edit kill on collision. Now, the bullet is being moved by something else, and we're going to be notified of some kind of collision. It should be an actual collision. And we will react to that here. So this is going to be the first one that we've written that doesn't use update, because we don't want kill on collision to do something every single frame. We only want some code to run when we actually collide with another object. And the autocomplete will not actually pick this up. So I'm going to look up Unity monobehavior. The autocomplete won't pick it up because it's not, the Unity messages are not really built. They don't really conform to C# in the way a lot of the other parts of the Unity API do. So on collision enter 2D, that is sent when an incoming collider makes contact with this object's collider in 2D physics only. So I like to just grab that like that. So just to see if this even works, I'm just going to debug log collide. Save that. Let Unity think. I'm just going to point this bullet at something, because we know it's going to travel in a straight line. So now it's pointing at this little bit of terrain, and I'm going to be watching the console to see if that script does what I wanted it to do. Oh, and speed is 0, so I'm going to set that to 1. Oh, we got collide. Great. So the reason I just did it that way is I really hate writing a pile of code just to discover that the thing isn't even being triggered. So now we have a confirmation that this code will run when we collide with something. And we can go on and sort of fill out this function with confidence that it's going to be called at the right time. I could even try to point it at the player. Let's see what that's like. Oh, I keep forgetting to set the speed. Boop. Boop. It hits the player and even moves the player. So Unity has two different kinds of collisions. There's an actual physical collision, which is what we're seeing, and a trigger collision, which doesn't move objects around, but just sort of notifies the system that two things are touching. And then you can do whatever you want with that information. I paused for a moment to figure whether or not we should use collisions or triggers, but I'm just going to try it out with collisions now until something, breaks or there's a reason to switch. So what we want is, we kind of have these two different things, right? If we hit the terrain, we want the bullet to vanish. If we hit the player, we want the player to vanish, or to, ideally to be actually killed and destroyed, and to stop the timer. So we want to check which object we're hitting. And the collision 2D, so the system notifies us, it gives us this object that has information about the collision. It tells us the collider of the object we just hit. It tells us where we hit the object, the game object that we just hit, the velocity that we hit at, so we could make it so that you only kill something if the bullet is moving above a certain speed. We're given a lot more information than just who we hit. We're also told how we hit them. But for now, we just care about the game object. Here's another just test. So now we're gonna try and get the bullet is gonna print out who we collided with, not just that we collided. Boom. And you see here it said collided with player. And then it kept on going and it hit the terrain and it said collided with terrain. So we can check what thing we're hitting and decide what to do based on that. And we could do that just based on the name. But you see here that the terrain tiles all have different names. We could give them all the same name if we wanted to. What I'll do, though, just for completeness, is use Unity's tagging system. It's also faster to do it this way. So we can create generic tags. Terrain and player. I think player may be a built-in tag as well. Oh, yeah. So now we can tag the player as player, and we can tag all the terrain tiles as terrain. And we can ask for the tag of the thing that we hit. So they could all have different names, but as long as they share as long as they have the right tag, our kill on collision script will know what to do. So now we could say, if the tag of the thing we hit is player, for the simplest thing we could do is just destroy the thing that we hit. Otherwise, if it is terrain, destroy ourselves. So this is equivalent to this.gameObject, right? Let's see if that works. Small changes, frequent jump-ins. The bullet could destroy the player, and the terrain destroyed the bullet. That's exactly the behavior that we wanted. So we got the vanish on terrain, delete player on player collision, and now we have bullets. And our player, the collision logic, that's kind of in. That sort of happened in the bullet. Now what we need are enemies that'll zip around and spawn these bullets at the player. And then we kind of have our first prototype. And we could start to see where this is interesting and start to build up on that. So I'm going to create an enemy. And it's got a sprite. I'm going to move through this as quickly as I can. There's our enemy. I want the enemy to move. So I'm going to give this guy an enemy mover. Bum, bum. So here's our enemy mover C# script. And I'm going to give you Unity's thinking. I'm going to give you also a circle collider. I'm going to shrink this down to yay big. Let's make you move forward on your... Seems like you move forward on your x-axis. So you can rotate the actual graphic to align with the movement axis, but where we're at right now, it's easier to just fix that in code. So enemy mover, bring that up. Think a little bit. So very much like the bullet mover. if you find yourself copying and pasting logic, it may actually make sense to just have, instead of a bullet mover and an enemy mover, you could have a, moves along axis script, which is, way more abstract. You're not talking about enemies or bullets, but if you make the observation that there's a lot of things in your game that kind of move the same way, maybe they should all use the same movement script. That's not a terrible idea. That's actually what entity components are kind of meant to do, right? You see this, like, everything's here. We keep seeing, like, all right, we're going to want a speed. We're going to move along. Instead of up, we're going to move along right this time. This should work. Well, we'll see. Oh, of course, I forgot to set the speed, but there's your speed. And it moves forward. And I was thinking of giving the enemy sort of a zigzaggy pattern, but that's the like instinct that you almost kind of want to fight. It's like, oh, it'd be really cool if he sort of moved in this weird way. It's like, no, I don't have a game yet. I want to get a game in place, and then we can start thinking about like movement patterns. The simplest thing is just an enemy moving straight. And I'm actually just going to position this guy sort of up here to sort of come from off screen towards the player. I'm going to move the player out of the way. So what do we got? We got the enemy art. Flight logic is basically in. Let's give him some aiming logic. So this is going to be the enemy gunner. So this one's going to look a little different from the other stuff that we've done, because it's going to need to spawn new objects as it goes. So immediately, now that I'm at this code, now that I'm writing the script that I hadn't even thought about before, I now need to figure out, like, oh, how frequently should these enemies fire at you? That's a thing to add to the next prototype. Firing frequency. So we already have a couple of questions for the next prototype, and we haven't even played this game yet. That's kind of what you want. You want to use the prototyping process not just to see if your ideas are good or bad, but they're almost like truffle swine, sort of sniffing out new avenues to explore. Things that you may not have occurred to you just when you were sitting down thinking about this game. But the act of actually building a prototype makes that stuff more apparent. And okay, cool. So the enemy gunner. So I'm just going to throw in public float, the frequency. I'll just make up a number for that, I guess. And leave the start thing in there. Gonna move quickly through this. I'm not gonna have a whole lot of. I'm not gonna be able to explain the semantics of game objects and prefabs. That'll come up for my students. That'll come up in class. If you're not one of my students, ask me on Twitter. I'll be more than happy to explain this. So I'm gonna drag. We have the bullet basically working. Unity's thinking. We have the bullet basically working the way we want it to. So I'm going to drag it into the project and make it into what Unity calls a prefab. Remove it from the scene. And now I can attach it to the enemy. And now the enemy has a reference to this game object and component collection that Unity calls a prefab. And we can use that to like make clones of it. And that's kind of what's going to happen. So again, baby steps. The simplest thing we could do is maybe every frame just create a bullet and just see what that looks like. We're not even using the frequency. This is probably going to freak out a little bit, but let's see what that looks like. Ah! You see that? It just spawned a bunch of bullets. Speed. So I'm going to give this plane a speed. So I'm going to try that again. I'm going to hit play, and let's watch what happens. So the object is moving, and oh, that's weird and great. I have like a little flame. So what happened is we're creating bullets, but we're creating them. We're not telling Unity where to put the bullets. So we can specify that by passing in a position. So let's create the new bullets at our current location. So to create the illusion of a ship, sort of an enemy firing bullets, we'll create them at our current location. And we have to give Unity a rotation. So we'll just use our current rotation. Why not? See what that looks like. Ooh. So now I have a plane. The bullets are coming out of the plane, but they're all firing off to the right. Again, I want to stress this. I didn't, try and get this whole thing right from the first go and then hit play, but I'm just sort of poking at it, seeing what Unity does, and adjusting by that. You really want this to be a conversation, ideally. This is, as a side note, why I believe in live coding as much as I do, because the closer you can get to a really tight loop between what the system thinks it's doing and what you want it to be doing, I think the more expressive you can be. So we're getting close to getting the broad strokes in. We have bullets sort of firing out, but they're always facing the right. And if you remember, the bullets move on the y-axis, and the enemy turned out to move on the red x-axis. So the bullets are just sort of moving along this the axis that we gave them, the axis that the enemy is at. If we turn the enemy during flight, we can see that the bullets are now firing up. So because of the way we built it, we have like a perpendicular bullets. We can pop back into the bullet mover script if we want and make it move along the same axis that the enemy ship moves along. Let's see what that looks like. That should just be firing forward now. Yeah, it is. But so they're firing so fast and they're colliding with each other. That's why we're getting that glitchiness. So let's try and make, if the enemy's moving at speed 1, let's jump into the bullet and make them move at speed 5. Whoa. So they're still colliding and creating this sort of glitchy double bullet effect. That's pretty funny. They may be colliding with the ship itself. So I'm going to turn off the ship collider and see what that does. Yeah, so they're totally colliding with the ship itself. And now we're just sort of spamming, we're like firing all these bullets. And it's starting to look like a bullet hell really quickly. You just sort of fire one bullet every frame, and then you kind of have it. So now the question is, okay, we hadn't specified this, so we kind of have to make it up. I think what I want is the sort of ships to just move down and fire at the player without turning to look at the player, if you know what I mean. As opposed to the ship steering towards the player and always firing forward. Although this actually sounds a little bit more interesting. And again, what you decide to do, how strict you decide to stick to your prototype plan is a part of your practice. I do, when I'm doing stuff, I try and follow like interesting paths when I see them. I'm imagining that it might be cool if you could like if maybe the terrain, if a enemy hitting the terrain maybe also deleted the enemy, and the enemies followed you. So maybe your motion, you could actually like lead them into terrain and like cause them to blow up. And that maybe becomes a way of you sort of surviving and advancing using only motion. So I kind of, yeah, let's do that. I kind of want to try that. So so what does that mean? Let's prototype that out. So our enemy aiming logic is actually now going to get a little more complex. We're going to want to make it find the player, look at player, and the collision logic, we want the terrain to kill it, right? Cool. So let's do the let's make the plane fly towards the player first. Let's do that. That's going to be, I'm going to pop back into the enemy mover. Actually, no, I'm not. So the enemy mover is fine. It's always just moving forward at a constant speed. What we need is an enemy steerer. Enemy steerer. I may or may not be a word. One who steals. One who steers. That which steers. Oh, and I think it's mad at me because I used the player tag, and that's a default built-in tag. That's fine. So, nope. So the enemy steerer is going to need to know it's going to need to be able to orient itself towards the player. So every frame, we're actually going to, one way to do this using linear algebra is, given the player and this ship or enemy, we know that the enemy is going to move forward on transform dot right. Again, we're moving to the right because of the way the graphic was oriented, because the art was drawn with the ship pointing to the right. So that's what forward motion just looks like. So what we want to do is we want to make this vector, this transform right, we actually want to point it at the player. So we want to set it to the difference between the enemy position and the player position normalized. So to be, linear algebra, to be like sort of mathematical about it, we want it transform right to become the enemy position minus the player position, and we want to normalize that. I forget is it the double bar is the normalized symbol? I forget. But what that looks like in code is we want to take so var equals player dot transform dot position, or our transform position minus player transform position, and then this whole thing normalized. And I'll be honest, we may have to switch the player and the local. I always forget the order of this stuff, and I kind of don't care. I just sort of, when the search space is 2, I just try both things until it works. Maybe that makes me a bad programmer. Who knows? And now we're going to say, okay, our new right is, because you can do that in Unity, which is pretty cool. So we could have also, figured out a way to do transform.rotate. There's also a transform.lookAt, which works better in 3D than it does in 2D, but that could also work. Or you could just use linear algebra, depending on what you're most comfortable with. The sort of vector math is what I can best wrap my head around. So let's see what. Oh, right. Now we just need to tell the enemy steerer that we want to find the player in the scene. Save. And let's see if that works. Ah! You see that? We're going the wrong direction. So just swap them up. One day maybe I'll learn. It's just so much easier to play around like this. Ah! Ah! Go away! Ah, I'm dead. We kind of have a playable game. Hooray! Let's try again. Ah! Ah! Dead. So just from that, we're not even done going through our punch list, but we finally got to basic interaction that I can sort of, as a player, parse. And just immediately from that, there's like stuff I want to tweak. It's like, okay, well, what if the player is like really slow? What if a player was actually faster than the plane and was as fast as the bullets? Whoop. Whoop. Ah, shit, I got caught. No. Oh, fuck. Oh, whoa. Physics glitches. Okay, let's try again. No. Boo. Okay, so, oh, shit. So 1 bullet per frame is probably too fast. But, well, I also can't stop this plane from attacking me, right? I think the, go away. Ah, shit. So I think the plane colliding with the terrain and having that destroy the plane, I think that might make this interesting. And you'll see we're getting all these like errors because enemy steerer at line 8 is trying to access the player after it's been destroyed. So we should really just check if player is unequal to null. Let's really then do that. And that should work. Whoop. Yeah, and now we don't get any errors. I'll keep on going. Cool. All right, yeah, let's make the plane collide with the terrain and die. And that'll give us, as a player, that'll give us a little bit more agency in terms of what we can do. So, you also notice, I just want to take a moment and say the project structure is a mess. I haven't separated things into separate folders. Everything is just sort of in the scene. I've only made one prefab because I absolutely had to. I try and not do things unless I absolutely have to. That's just a general rule. Like I try and not introduce structure or complexity unless like my hand is forced. That's just I found like what allows me to keep moving quickly and not get hung up on like details, especially in this early in the prototyping phase. Okay, so let's make these planes explode when they hit the terrain. That's gonna be its own script. Yeah, it's gonna be its own script. So enemy collision. So enemy collision. Let Unity think about that. Bring it up. So there's another problem here where we also, I had the collider turned off. If I turn it on, before we even get to the collision logic, actually I should do this. We have this problem of the bullets are kind of colliding with the ship. What's happening is we have ship. It's got its own collider, and we're spawning the bullets here, and they're kind of sometimes glitching out before they head out. So what we could do is, instead of spawning them at the location of the ship, let me jump back in. So instead of spawning them at the center of the ship, we could spawn them here, like outside the collider, and make them go off. And that way they don't ever collide with the ship. And a nice way to do that, easy way to do that is transform.right times, actually 1 should be fine. So basically, whatever the position of the object is, we're going to move along its right axis. And that allows us, and that's where we're going to spawn the bullets. And that way the rotation will continue to work. I'm not fast enough for this. I'm like holding left to dodge the bullet. You see that indeed it does work, and it doesn't hit. I definitely feel like the frequency is absurdly high, but that's something that we can deal with in a little bit. So now we have the collider of the ship re-enabled and not interfering with the bullets. I'm going to give it a rigid body so that we can detect collisions and say that it is not affected by gravity. Now I can go back in and grab this on collision, enter 2D signature, and just replace the whole body with that. There we go. So now the enemy collision, now we want to say if the game object we're colliding with, if its tag is the terrain, we want to destroy ourselves. And we can even, I think we had this spec'd out. Right, so we even want the collision with the enemy to kill the player. Although I don't think that'll ever happen with this many bullets. But let's just put that there for completeness. So if you hit the player, destroy the player. Destroy the game object of the thing that we hit, which is the player in this case. So let's see if we can lead a plane into the terrain and cause it to die. Woo! Survived. So now we have a way, let's actually cross that out. We didn't test this, so I'm gonna cross it off because the code is there. It's kind of hard to test. So the player is basically done. Our enemies, we were able to find the player and look at the player. That's done. The terrain kills them. That's done. Aiming, done. Enemies, done. Players are done. And the collision logic of the terrain is done. That is basically our first prototype. Now we can create a couple of enemies. This is going to be a nightmare. Yeah. So, I guess the one thing we didn't really do is the frequency of the bullets. Let's just do that and then call it, because then everything else, I think, will work for future prototypes. And it's been, what is this, 2 hours 15 minutes? That's not bad. I was sort of between two and 2.5 is sort of what I had in mind. So one way to do the frequency, there's no way to ask. There's a couple of ways to ask Unity to run code on a sort of timed loop. So instead of every frame, run it once every certain amount of time. And you know what? Yeah, I'm going to do that. I'm just going to use what Unity calls a coroutine. So this is going to be a little bit advanced. Definitely have not looked into this in class. This is one of the best things about Unity, I think. So we're going to create this fire bullets logic. It's the same thing, right? We spawn a bullet. with the correct orientation. And, but now we could do this. Return new, wait for, ooh, that's a new one. So now frequencies actually will be mislabeled. Let's call this time between bullets. It's not really the frequency. So now we have this fire bullets function that will fire a bullet and then wait for a certain amount of time. And it returns an IEnumerator, and you got to say yield return new. And that's what allows you to do this. So when we start, we can do that. And that basically sets up this infinite loop within which is a pause that happens across real physical time. And that's what Unity coroutines allow you to do. Don't have time to get into more detail than that, but I'll throw up a link to the coroutine documentation. And in class, we'll definitely be going over that. It's one of the best things about Unity. And I'm going to jump back in and remove these extra enemies and see if that actually did it. Boom. So here's our enemy. And I'm going to say the time in between your bullets. And this is measured in seconds, so let's say 5 seconds. Let's see what that is like. Boop. Yeah. I'll wait 5 seconds. Yep. And the terrain covers it. Awesome. So maybe one, is that more interesting? A little bit. Yeah, it's not quite a bullet hell, but you know, they'll get you. I just died. And now we can create a bunch of enemies. So things that come to my mind are, okay, well, how do we spawn more enemies as the game goes on? Immediately dead. Oh, right, because they fire and then they wait. Check this out. What if we wait and then we fire? That'll give us like a moment to start moving before the first shot goes off. Dead. And they all fire on the same time. So that's a really solid first prototype. Built in under 2 hours. And the important thing here is that now you have something that you can play, that you can tweak, that you can start generating questions from. Like, the firing frequency, we already noticed that. They're all firing at the same time. So maybe the firing offset, how do you get the planes to fire at different rhythms as opposed to being all in sync? Or is the fact that they're all in sync interesting? Spawning enemies at runtime instead of just having set number of enemies just created by hand. Spawning at runtime, this is the enemies, is what I meant. Procedural terrain is another thing, right? It's just like this hand-coded bit of terrain. But really you'd want to give this to I mean, this is maybe a prototype that's too early to give to playtesters because there's not a whole lot there. But you and your team and your peers can play around with it and start to figure out what next steps would be. And then that becomes the next prototype. The point is that you have this thing. It's going to keep playing it. Going to maximize on play. still too hard. I want to see if I can get through a whole thing and just like defeat all of them. Fuck. Shit. Oh, there we go. I hit an enemy and then I died. Shit. Fuck. What if I started off a little safer? I'm just going to go ahead and give this terrain. Let's try that. And that guy on the bottom is going to try and get me. Ah, shit. So maybe the bullets are moving too fast. Let's go to the bullets and actually bring them down to 2.5. So now I'm just tweaking, right? Ah, leave me alone. Boom. 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 Oh, and he shot me through the face. That's pretty funny. And then that felt too easy, right? So it's either too hard or too easy. But now you can sort of take that back into brainstorming and building out another punch list and figure out like, well, what makes it too hard? What makes it too easy? We have like power-ups as a dangling thing that we haven't explored yet. Maybe power-ups go into the next prototype, right? But the key thing is we got to a playable state in one sitting. And we didn't get hung up on details. We didn't overanalyze or overthink things. We got something down on paper, something that we can build on. We have a bunch of code we can reuse, some stuff we can, tweak to try and make the experience more interesting and more playable. And we're sort of off and running now. We've got the idea out of our head and out into a computer, and we could start figuring out the best way to build it towards a really engaging experience. And that's what is really meant by the kind of prototyping that I want my students to do, and that I think game designers in general, myself, even when I sort of forget to do this and get hung up, this is what I should be doing. So that's all I wanted to cover. I wanted to get sort of from very scratch to a state like this as quickly as possible. And that's basically it. So I hope this was helpful to you if you're watching it live. I hope this is helpful if you're watching it on YouTube. And I wish you the best of luck making your games. So it's going to pop up OBS and kill the stream.